Hi everybody, welcome to week 4. We have left the define phase. We are now in the measure phase. So with your course projects, you should be working on data collection. And while you're working on data collection, think about how you're going to report that data. So are you going to make a scatter plot? Are you going to make a histogram? Are you going to put things in a Pareto chart? What are you going to do with it? Also, while you collect the data, think about how that figure that you're putting in your data is going to look, because it's very easy to report data in a way that makes certain trends apparent that aren't actually there. Let's take a look at a histogram that's like this, because this is very easy to kind of warp what data looks like using a histogram. So here we've got two histograms. This is actually from a published peer-reviewed article that I found last week. I was doing some research on milk protein concentrate and solubility, and I found these graphs, and I said this is perfect to show to the class, because if you look at the difference between protein heat treatment on the left and oil heat treatment on the right, they're trying to increase the solubility of milk protein concentrate powders. Now, the bar on the far left on each graph, the PU/OU, that's the control. Everything else is some kind of treatment. So it looks like their treatment worked really great, especially with the protein. The protein had a much bigger effect than the oil. But then if you look at the numbers, no, it didn't. Because solubility runs between 0 and 100%. And the graph axis on the left runs between 38 and 52%. The graph axis on the right runs between 0 and 60%. So already we're not using the full scale, and we're not even comparing these figures on an equal basis, because the y-axis scales are different, so we can't make a comparison. The best we can do is look at the numbers on top of each bar, and that's the percent solubility that each treatment, each sample had. So our control is 42.4% soluble. That means we could dissolve 42.4% of it in whatever solution we had. Okay, that's our baseline. No problem with that. But if you look at the height of those two bars, it doesn't look like the same treatment, even though that's the exact same data. Now, if we look at the effect that the protein heat treatment had, okay, so we go from 42.4% to 46.7%. With the next treatment over at 60C, the highest one was 50.4%. If you're operating on an industrial scale, this is really good, because this can actually save you a lot of money. But if you're operating on a lab scale and you're thinking about this in terms of grams, that means you have basically 8 more grams dissolved. But the bars make it look like a lot more got dissolved, even though it's only 42 versus 50% soluble. Now, if we look at the right, we had better solubility. The highest one there was 52.2, which again, on an industrial scale is great. That increase between 42 to 52% solubility is fantastic on an industrial scale, where you're dealing with tens of thousands or hundreds of thousands or millions of pounds of product a year. But again, on a lab scale, it's not that big a deal. Your treatment didn't have that much of an effect. And oddly enough, the oil heat treatment looks like it actually wasn't as effective as the protein heat treatment if you just look at bar height. If you were just looking at bar height, you'd say, oh, I want to do that protein heat treatment at 90C. That looks like it's the best one, even though it's not. The oil treatment at 60C is the best one. So the lesson here is that you can make your data look like whatever you want to by playing with the scale, even though that may not be the reality. So as you're going through and you're creating figures for your own data in your projects, be very careful how you're representing that data. Make sure the scale is representative of the full range of responses you can get, and make sure you're not fooling yourself into thinking something looks a lot better than it actually is because of those scaling issues.